All right, test tomorrow is super similar to the quiz, but it has 9.4 on it too, so the graphing, sine, and cosine functions. All right, so let's convert. Let's do number 3. So to convert from radians to degrees, we're going to multiply by 180 over pi. A lot of people did well on the converting questions on the quiz. The pi's cancel. 2 goes into 180 90 times. Then we have negative 9 times 90 would be negative 810. Awesome. So just be careful with the math here when you're simplifying too. I think where people went wrong on the quiz was just that they simplified incorrectly, kind of just rushed it and multiplied wrong. So. Yeah, if it's negative 9 times 90, so.
Are we going to have calculators on the test?
No calculators. All right, let's do number 4. So here we're converting to radians. So we're going to multiply by pi over 180. Simplify. 5 goes into 75 and 180. How many times does 5 go into 75? 15. Yep. And how many times does 5 go into 180? 36. Can we simplify any more? Does anything go into both 15 and 36? 3. Awesome. 3 goes into 15 5 times, and 3 goes into 36 12. Can we simplify any more? No. So we're left with 5 pi on top and 12 on the bottom. All right. Next, let's find the reference angle. So step 1, when finding the reference angle, we want to start with an angle in between 0 and 360. Reference angles are like a smaller version of the original angle. So if it asks for a reference angle of a degree, make sure your answer is in degrees. If it asks for a reference angle of a radian, make sure your answer is in radians. And then we also have to know 2 things about our reference angle. It is always positive. And what else? Acute, meaning that it's less than 90. A lot of people struggled on the quiz with the reference angle questions. To find your reference angle, it depends on what quadrant you're in. If you're in the first quadrant, whatever your reference angle is, or whatever your theta is the same as the reference angle. Bless you. In the second quadrant, we do 180 minus theta. Third quadrant, theta minus 180. And fourth quadrant, 360 minus theta. Now, if you accidentally use the wrong formula in the wrong quadrant, your answer is not going to be positive and not going to be acute. So you can kind of check yourself that way. So starting with number 5, is negative 325 in between 0 and 360? No. So what can we do to make it in between 0 and 360? Add 360. What do we get when we add 360? 35. What quadrant's 35 in? The first one. So what would our reference angle be? 35. Awesome. What about for number 6? Is 620 in between 0 and 360? No. So how would we make it in between? Subtract 360. What do we get when we subtract 360? 260. 260 is in quadrant 3. So we'd do 260 minus 180. What do we get? 80 degrees. Perfect. 80 is acute and positive. What would we do first for number 7? We got to convert it. So we're going to multiply by 180 over pi. Pi's cancel. 5 goes into 180. How many times? 36. So this would be negative 36 degrees. Awesome. Negative 36 is not in between 0 and 360, so we have to add 360. We get 324. Which quadrant's that in? Awesome. It's in quadrant 4, so we do 360 minus 324. And what do we get? 36 degrees. 36 degrees, but can our answer be in degrees? It has to be in radians, so we have to convert back. So multiply by pi over 180. Awesome. 36 goes into 180 5 times, so it'd be pi over 5. Let's do number 8 too. So same steps as the last one, we have to convert it. So we're going to multiply by 180 over pi. Pi's cancel. 12 goes into 180 15 times. Awesome. $11 times 15 would be what? 165. Awesome. If you can't do that in your head, write it down. You guys do not get calculators for tomorrow, but you can multiply 15 times 11 and write it down. So we get 165. What quadrant would that be in? Quadrant 2. In the second quadrant, we do 180 minus theta. So 180 minus 165 would be 15. Can we leave our answer in degrees? No, it has to be in radians. Perfect. We're going to multiply by pi over 180 to convert it back to degrees. 15 goes into 180. We said 12 times. So that'd be pi over 12. So that would be our answer. Okay. For the next section, we want to find one positive and one negative coterminal angle for each. Coterminal, we add or subtract 360, or if it's in radians, we can add or subtract 2 pi. Because 360 and 2 pi are the same. So for number 9, it's in degrees. So to find a positive coterminal angle, what would we do? Add and subtract 360. To find a positive one, we'd add 360. So negative 265 plus 360 would be what? Awesome, 95 degrees. So that would be our positive coterminal angle. To find a negative one, we'd subtract by 360. Awesome, negative 625 degrees. Don't forget the degrees symbol if you're talking about degrees. So the questions on the quiz about coterminal angles were, I think it said like, which one of the following is a coterminal angle? So remember, you can add and subtract, add or subtract as many times as you need to find one of those angles. I think it kind of asked it in a different way on the quiz, so it maybe confused a few people. You can add or subtract 360 as many times as you want to find one of the angles.
For number 10, can you like convert it into like degrees and then subtract?
You can definitely convert it and then add or subtract 360 from there, but don't forget to convert it back.
Okay. If you convert it, like whatever you get once you convert it, does that count as a...
But you have to convert it back. If you're finding a coterminal angle of like a radian, your answer has to be in radians. So instead of converting it, I'm just going to add 2 pi and subtract 2 pi. If we add 2 pi to find our positive coterminal angle, what do we need in order to add here? How do we add fractions? Common denominator, so we're going to multiply by 4, so it makes it 8 pi over 4. 3 pi plus 8 pi would be 11 pi over 4. So this would be our positive coterminal angle. And then to find a negative one, we just subtract 2 pi. So we have 3 pi over 4 minus 2 pi. Again, we got to do the same thing. We're going to multiply the top and the bottom by 4 to have a common denominator. So it'd make it 8 pi over 4. 3 pi minus 8 pi would be negative 5 pi over 4. So this would be our negative coterminal angle.
Wait, what was the...
Right. 11 and 12, we have to draw the angle in standard position. So if it gives us radians, we want to convert it. So let's multiply by 180 over pi. Pi's cancel. 6 goes into 180 30 times. So negative 7 times 30 would be negative 210. Now, since we have a negative angle, if you want to, you can just draw your angles backwards. So instead of being 0, 90, 180, 210, 270, sorry, 360, we could do it backwards and say negative 90, negative 180, negative 270, and negative 360. So if we have quadrant 1, 2, 3, and 4, what quadrant would negative 210 be in? Which quadrant? The second quadrant. It'd be in between negative 180 and negative 270.
Would you just also add 360?
You can, if you want, you could add 360 to find the positive version of it, and it would be this angle. So yeah.
You can't do it like down.
So, I mean, that's what we did here. We started at 0 and went down and around 210.
But would you also mark it right if it was like you just add 360? And then
So you can add 360. What did you get when you add 360?
150?
150. So your 150 angle would be here. Just know that it's going to end in the same spot, but a negative angle starts by going down. So
Yeah, so if you just put it down like that, would you get
be the same.
right?
Yeah.
Okay.
Yes. For number 12, we know that we go around more than one time. Oops, it's positive, so we start by going up. We go around more than once. How much more are we going around? Subtract 360, awesome. So we get 110 degrees. What quadrant would 110 be in? The second quadrant. So it'd be kind of closer to 90 than it is to 180, so it'd be about here. Yep. Number 12 says use the unit circle to find 6 trig functions for theta when theta is 630 degrees. 630 degrees is not on our unit circle, so what would we need to do to find where it is, where it would be on our... Awesome, minus 360. We want to find the coterminal angle of it. When we subtract 360, what do we get? 270. Awesome. So we're going to go to 270 degrees on our unit circle. Our point would be 0, comma, negative 1. So let's write our 6 trig functions. We have sine, cosine, tangent, cosecant, secant, cotangent. Now when we use the unit circle, we don't use r. So sine would just be y, cosine is x, tangent is y over x, and then secant would be 1 over y, secant would be 1 over x, and cotangent would be x over y. So when you're using the unit circle, you don't use r.
When do you use R? What ones do you use R for?
Like for 13, when you're not using the unit circle, we'd have to find r. The only time you don't use r is when you're using the unit circle. So sine would just be y, so that's negative 1. Cosine is just the x, so that would be 0. Tangent would be negative 1 over 0, which would be what? Undefined. Awesome. If 0 is on the bottom, it's undefined. Cosecant, we'd flip it, so it'd be 1 over negative 1, which simplifies to what? Negative 1. Perfect. Secant would be 1 over 0, which is undefined. And cotangent would be 0 over negative 1, which is 0. Awesome. So for 13, it's not on the unit circle, so we have to find r. So we have x, y, and we need to find r. To find r, we're going to use our Pythagorean theorem. So we know that 7 squared plus negative 24 squared is equal to r squared. 7 squared is 49 plus 24 squared. Let's just write it out because I think this was a question from the quiz. 4 times 4 would be 16. 4 times 2 is 8 plus 1 would be 9. Put a 0. We have 2 times 4 would be 8. And 2 times 2 is 4. So it'd be 576. Is equal to r squared. 576 plus 49. 625
Yes, 25.
is equal to r squared. Take the square root. We got to make sure that this simplifies. So if you don't see that it simplifies right off the bat, we know that 5 goes into 625, so break it apart. Let's see what the square root of 625 would be if it is a perfect square or if it simplifies. Either way, we got to simplify it. So 5 goes into 625. How many times? 125 times. 5 goes into 125, 25 times, and 25 would be 5 and 5. So you have a pair of 5s and a pair of 5s. So what would come to the outside? 5 times 5, which would be 25. So our r is 25. So let's write our 6 trig functions. We have sine, cosine, tangent, cosecant, secant, cotangent. Sine would be x over r. Cosine, oops, yes, y over r, sorry. Y over r, cosine is x over r. Tangent is y over x. Then we have our reciprocals, which we can just flip. So sine would be y over r, would be negative 24 over 25. Can we simplify this?
Just to positive 24. Which one is positive?
No, because 25 is positive, so it's just negative. Can't simplify. Always double check to make sure you can simplify or not. Cosine would be 7 over 25. Can't simplify this. Tangent would be y over x. So that would be negative 24 over 7. Can't simplify that either. Now we can take our reciprocal function. So 25 over negative 24. 25 over 7. And 7 over negative 24. So these would be our 6 trig functions. Questions here? All right, last page. 14 says, given secant is equal to 8 in an acute triangle, find all 6 trig functions. So secant is equal to 8. We've done questions like this where it gives it to us as a fraction. So 8 as a fraction would just be 8 over 1. Now secant goes with cosine. And cosine, according to SOHCAHTOA, cosine would be adjacent over hypotenuse. So secant would be hypotenuse over adjacent. How do we find the opposite? Pythagorean theorem. So here, be careful when doing Pythagorean theorem. It always has to be equal to your hypotenuse squared. So we have 1 squared plus, if you want, you can call it opposite squared, is equal to 8 squared. So 1 plus, I'm going to call it A instead of O, just because, or you could call it B. I don't know, O just looks like a 0. We'll call it B squared. is equal to 64. Subtract 1. So b squared is equal to 63. Take the square root. Let's see if we can simplify the square root of 63. What are two factors of 63? 7 and 9. What are two factors of 9? 3 and 3. So what is the square root of 63?
3, 5,
3 square root
3 square root
7.
7.
7's left on the inside. So our opposite would be 3 square root 7. So let's find our 6 trig functions. Sine, cosine, tangent, cosecant, secant, cotangent. So according to SOHCAHTOA, sine is opposite over hypotenuse. So that would be 3 square root 7 over 8. Cosine is adjacent over hypotenuse, so that would be 1 over 8. And tangent is opposite over adjacent, so 3 square root 7 over 1, which would just be 3 square root 7. Now for our reciprocal functions, cosecant would be 8 over 3 square root 7. Can we leave it like this? What do we have to do? Multiply by square root 7. We have to rationalize. So on the top, we get 8 square root 7. And on the bottom, square root 7 times square root 7 would be 7. But we also have a 3. What's 3 times 7? 21. Secant was already given to us. It'd be 8 over 1, which is just 8. And cotangent would be 1 over 3 square root 7. Again, we have to rationalize, so we're going to multiply the top and the bottom by square root 7. So we get square root 7 over what? 21. Perfect. Again, this would be 3 times 7, which is 21. Any questions? All right, next we're going to solve the following using special right triangles. So in a 30, 60, 90 triangle, if our acute angle at the top is 60, that means the other one down below is going to be 30. Opposite of the 30 is A. Opposite of the 60 is A square root 3, and our hypotenuse is 2A. So we need to solve for A. We're going to take the equation that we have an answer for and solve for A. So we're going to divide both sides by square root 3. So A is equal to 8 over square root 3. Can we leave our answer like this? No, we have to rationalize. So multiply the top and the bottom by square root 3. We get 8 square root 3 over 3. So that's our A. So we're going to plug that in. So X is equal to 8 square root 3 over 3. What would Y be equal to? 16 square root 3 over 3. We just have to multiply the top by 2. Questions here? All right, 16, we're doing the same thing. We have 45, 45, 90 triangle. Opposite of the 45s is just A. And our hypotenuse is A square root 2. So A is already solved for us. So what does X equal? 10. And what does Y equal? 10 square root 2. Perfect.
Can you go back to 2?
All right, 17. Here we need to identify the amplitude, time period, increment, and graph. So first, we can identify our amplitude. What would our amplitude be? 6. Awesome. Which means our graph is going to go up to 6 and down to negative 6. What is the period?
1, 2,
How do we find the period?
2 pi over b.
2 pi over b. And what's our b here? 1. B is whatever gets multiplied in front of the x, which here is nothing, so that would just be 1. So our period would just be 2 pi over 1, which is 2 pi. And then how do we find the increments? Period over 4. So that would be 2 pi over 4, which simplifies to pi over 2. So our period is going to go to 2 pi. Our increments, we're going to start at pi over 2. How do we find the next increment? Add another pi over 2. So to find the next one, we're going to add pi over 2. What's pi over 2 plus pi over 2? What does 2 pi over 2 simplify to? Pi. Then to find the next one, we're going to add another pi over 2. What is pi plus pi over 2? 3 pi over 2. If you guys need to, write it out. We said that pi was 2 pi over 2. Or just find a common denominator. When we add another pi over 2, we get 3 pi over 2. So you just add your increments. You're going to have 3 increments in between 0 and the period. Here we have a cosine graph. Where does our cosine graph start? Starts at the amplitude. So we're going to start up at 6. And remember, our graph just bounces back and forth between the amplitude. So between 6 and negative 6. Where would our next point be?
pi 2, 0.
At pi over 2 at 0. And then at pi, where would our next point be? Negative 6. At 3 pi over 2, back to 0. And then at 2 pi? At 6, up at the amplitude. So your graph's always going to start and end at the same spot. Then we just connect our dots with a curve. All right, let's do the same thing for 18.
How do we know, how it goes?
Not for tomorrow. That'll be a 9.5. All right, last one, let's do 18. So first, let's find the amplitude. What would our amplitude be? 1 over 5. So we're going to go up to 1 over 5. Where did it go? And then down to negative 1 over 5. And then let's find the period. How do we find the period? 2 pi over b. And what's the b here? 6. Awesome. So that would be pi over 3. So our period is going to end at pi over 3. And then how do we find the increments? Period over 4. So pi over 3 over 4. This one's fun. How do we do a fraction inside a fraction? Keep, change, flip. We're going to keep the top, change to multiplication, flip the bottom. The bottom would be 4 over 1 because it's a whole number. So when we flip it, we have 1 over 4. How do we multiply with fractions? Straight across. So that would be pi over 12. So our first increment is going to start at pi over 12. Then we add pi over 12 to get the next one. Pi over 12 plus pi over 12. 2 pi over 12, which simplifies to pi over 6. To find the next one, we're going to add another pi over 12, which would be 3 pi over 12, which simplifies to pi over 4.
Do you have to simplify it on the test?
Yes, make sure you simplify your fractions. So here, because it's a sine graph, our question says sine. Where do we start? Starts at 0. So we're going to start at 0. Then we always go up to the positive amplitude, back down to 0, down to the negative amplitude, and then back to 0. So our graph would look like that.
For both cosine and sine?
Yeah, when you find the period, that's going to be the last number on your graph. So the period here was 2 pi, so we end at 2 pi. It's like where your graph ends. Remember, your graph needs 5 key points, which it's going to have like 4 tick marks, I guess, 4 parts of the x-axis. Your period's going to be one of them, and then you need 3 increments before there.